Everyone, welcome to Unravel Logic channel. In today's video, we'll be learning about standard deviation. To understand this better, you need to know about variance, which I have covered in my previous video. So let us start. Standard deviation. As usual, let us start with the formal definition. So this is formally defined as root mean squared deviation or root of mean of squared deviations. Let us understand this now. Root mean squared deviation, root of mean of squared deviations. So if you remember the definition of variance, it was mean of squared deviations. So for standard deviation, what we are simply doing is root of variance. So if you call this as variance, this becomes standard deviation equals square root of variance. So when we say root, we simply mean square root in most cases. So this is what it is, square root of variance. Now let us see the mathematical formula right away. So we have already written it in words, right? And now let us see how it looks in mathematical terms. Okay. Formula goes something like this: standard deviation of x is equal to square root of variance of x. As simple as that. Let us see in mathematical terms. So let's do the square root. Summation of I is equal to 1 to n, and then we are simply writing the formula of variance, right? And just doing the square root, right? So square root of summation of the squared deviations and we find its average, right? So that is also called as sigma, right? Which is standard deviation. That is also called as sigma. So let us see the what does each notation means, right? So this is sum. This is simply square root. This is the ith observation. This is x bar on mean, and this is sigma. We call it sigma, okay? And this is number of observations in your data set, because we are finding the average of squared deviations, and then average of squared deviations, and then the square root. So that is standard deviation or sigma. Now let us understand why this is required when we already have variance. So the only difference between variance and standard deviation is that for standard deviation we are doing the square root, correct? So why is that necessary? Okay, what is the advantage that we get by square rooting the variance? So let us understand that now. While variance amplifies larger deviations because we square the data, we understood this in when we are studying the variance. So variance amplifies larger deviations because we are squaring the data. The squaring the data itself makes the unit of variance as square of the unit of observations. So what do I mean by this? So when we say that if my observations, if I am recording the days it takes for a tomato to ripen, right? So ripening time of a particular tomato or a typical tomato, if I am observing that data, the unit would be days. So for example, a tomato takes 72 days to ripen, right? So this is my unit of observation. Okay, days is the unit of observation. Now if I find the variance of this, the unit of variance would be days square. Okay, days square. So notice the square here. Okay, now this is a bit harder to grasp or interpret, because if let's say the variance of this comes as for example, uh, let's say 144 days square, for example. Okay, now what does this quantity means in terms of the observations that we are seeing? So we are seeing that a tomato takes 72 days to ripen, but the variance is 144 days square. The only thing that it would probably tell you is that the data is spread out too much from the mean, just like we understood this while we were studying variance, right? But this still doesn't make too much sense individually, right? So what we did to make sense of this data is that we compared this with another data set, wherein again we had the days it would take for a tomato to ripen, and then we found out variance, which was, let's say, I'm just writing dummy data, which was, let's say, 84 days square. Okay, now if you compare these two data sets, right, then it makes sense that data set 1 has a larger spread, degree of spread is more in data set 1, degree of spread is less in data set 2, so data set 2 is more consistent. But it still doesn't make sense individually. If you see this 144 days square, it doesn't tell you too much. Okay, so let me write variance amplifies larger deviations. The unit becomes squared now. In case of standard deviation, the unit stays the same, because we are finding this data which is 144 days square, and then we are square rooting it. Okay, correct? So the unit again comes to days instead of days square. Okay, this is for standard deviation. Okay, now let us try and understand this with an example and really understand what does it mean when we square root the variance, and how does it help us understand the data better as compared to variance. Okay, so let us understand this concept by comparing battery lifespan of two smartphone models. So basically smartphone is in the phone that we use in daily life. Okay, so let us compare the battery lifespan of two phone models. Battery lifespan phone models. So for model A we have 10 hours, 11 hours, 9 hours, 10 hours, 10 hours. Model B 5 hours, 15 hours, 8 hours, 12 hours, 10 hours. So this is basically, we have observed the battery lifespan for multiple days. Okay, so for model A, one day we got 10 hours of battery life, another day we got 11 hours, then another day we got 9 hours, following day 10 hours, and then following day 10 hours. Similarly for model B, 5, 15, 8, 11, 12 and 10. Okay, these numbers are in hours. Let us write this to avoid confusion. Again, in hours. Okay, so we have these observations. Now let us calculate the mean, variance and standard deviation of these two models, the data set for these two models. Okay, and to save time, since we already know the formulae and the formulae are very easier, right, to calculate, so I have calculated this, I have pre-calculated this, and I will just write the data. So data is like this. So 10 hours, 10 hours. So again the mean is same. So notice that in all my examples of, for example, variance or standard deviation, I always keep the mean. I always choose data which has the same mean, so that we are easily able to understand the differences, the effect of a standard deviation or variance, right? So that is the reason I am keeping the mean same, so that there is no effect of mean that we need to consider while understanding standard deviation. We only need to understand the effect of a standard deviation or variance. Okay. Variance is 0.5 hours square. Let's take note of the unit. It's hours square. This is 14.5 hours square. The standard deviation is 0.71 hours. See, the unit is equal to the unit of mean or the unit of observations itself. There is no square here. This is 3.81 hours. Okay. Now notice the numbers of a standard deviation. 0.71 hours and 3.81 hours is more intuitive as compared to 0.5 hours square and 14.5 hours square. While variance here is clearly conveying that the battery span of model B is very inconsistent. Okay, so variance tells us that battery span of model B is inconsistent. Okay. The standard deviation gives us a little more information. Okay, so standard deviation gives us a little more information by telling us that on an average, okay, on an average, the battery span of model B will deviate 3.81 hours, deviate by 3.8 hours from the mean of 10 hours. Okay. So for example, if you were to observe the data of model B for one more day, you would get the battery lifespan somewhere around 13 or 7.5 hours, which is 3.81 hours from the mean, which is like 10 plus 3.81 hours or 10 minus 3.81 hours, right? 6.2 something or 13.81 something. What it is saying is that the data would be very close to these two numbers, somewhere between these numbers. So that gives you some kind of confidence. Okay. But if you look at the reading of variance, which is 14.5 hours, okay, 14.5 hours square, what does it tell you? It doesn't tell you much. It just tells you that there is a high degree of spread when it comes to model B. The data is very inconsistent. Okay, but standard deviation gives you a range wherein the number would lie most probably. Okay. The reason standard deviation is easy to improve because the units are same. So after doing this analysis on the battery life span of both the models of phones, we can come to a conclusion that if I were to buy a new phone, it would be of model A. Okay. Because the standard deviation is 0.71 hours, which means that on an average the battery lifespan of model A would range, most probably would range from 9.29 to 10.71 hours, which is very good considering that I can simply trust the value of mean. And in other words, you can also say that standard deviation, if it is low, you can trust the mean value more and more. The lower the standard deviation, the more you can trust on the mean value. Because 9.29 and 10.71 is very close to the mean of 10 hours. Okay. So while analyzing data, you can simply calculate standard deviation after mean depending on the type of data and the context of your analysis. Standard deviation has some important properties with regards to normal distribution, but we'll cover those properties in later videos when I will explain what normal distribution is, what is the significance of normal distribution, why is it important, how it gets formed and everything. And then we'll again cover the standard deviation with respect to normal distribution and why is it important. But yeah, for now, I hope you understood the concept using this battery and phone model examples, right? And yeah, see you in the next video. Thank you for watching. Please like, share and subscribe for more such content that would give me inspiration to create more videos for you guys. Thank you.